Have you ever just stopped and thought about the absolute magic that's happening inside your head at this very moment? We're about to take a journey into one of the most incredible pieces of biological engineering you can imagine, the human ear. And trust me, it's so much more than what you see on the side of your head. It's a precision instrument that turns invisible waves in the air into your entire world of sound.
So this is the big question, right? How on earth does a simple, invisible vibration get turned into the richness of music, or the meaning in a conversation, or even the warning of a car horn? It really does seem like magic, but as we're about to see, it's actually an astonishing feat of engineering.
All right, so here's our roadmap for this explainer. We're going to start with why the ear is such a marvel, then we'll travel from the outside in through the outer, middle, and inner ear. And then we'll wrap up by looking at this surprising partnership between our hearing and our sense of balance.
Okay, first things first. Most of us just think of the ear as having one job, hearing. But its design is this beautiful masterpiece of efficiency because it's actually handling two totally different but equally vital functions at the same time.
And here they are, those two big jobs. You've got audition, that's the scientific term for hearing, and then you've got equilibrium, which is our sense of balance. It's kind of mind-blowing that this one organ is responsible for both perceiving sound and giving our brain the constant feedback that lets us walk, run, and just stand upright without falling over.
Let's start our journey with the only part of the ear we can actually see. The outer ear is perfectly shaped to act like a natural funnel. Its whole job is to catch sound waves from the world around us and guide them deeper inside.
And it's really made of three key parts. First, there's the auricle, or pinna. That's the cartilage on the outside of your head. And those unique folds and curves, they're not just for show. They actually help you figure out where a sound is coming from. From there, the sound waves are funneled down the external auditory canal, which is just a short tube that leads right to the tympanic membrane, which we all know as the eardrum.
And right here, this is the first incredible transformation. The eardrum is this thin, tight membrane that works exactly like the surface of a drum. When the sound waves traveling through the air hit it, it vibrates. It's the gateway, basically translating the energy from the air into a physical mechanical motion.
Now, once we pass through the eardrum, we enter the middle ear. I want you to think of this tiny air-filled chamber as a mechanical amplifier. Its whole purpose is to take those subtle vibrations from the eardrum and make them way, way stronger.
So how does it do that? With the three smallest bones in your entire body, the ossicles. You can see their names and shapes here. You've got the malleus, which looks like a hammer and is attached to the eardrum. Then there's the incus, or anvil, which acts as a bridge. And finally, the stapes, which is shaped just like a stirrup and connects to the inner ear. These three little bones work together like a powerful lever system. And get this, the sheer power packed into this tiny chain of bones is just astounding. They take that initial vibration from the eardrum and amplify its force by 20 to 30 times. That's a huge boost, and it is absolutely crucial for the next step in the process. Now, also hanging out in the middle ear is something called the eustachian tube. It connects to the back of your throat, and its main job is to keep the air pressure equal on both sides of your eardrum. This is exactly what's happening when your ears pop when you're on an airplane taking off or landing. It's just that little tube opening up to balance everything out.
Okay, now we're arriving at the most intricate, most mysterious part of our tour, the inner ear. It's often called the labyrinth, and for good reason. It's this complex, fluid-filled maze where that amplified mechanical energy finally gets converted into electrical signals that your brain can actually understand. It's the digital converter of the system. And inside this labyrinth, we find these highly specialized structures. You have the cochlea, which looks just like a tiny snail shell, and it is dedicated 100% to hearing. Then you have the vestibule and the three semicircular canals. These are the headquarters for our sense of balance. It's all happening right here in this tiny, complex space.
So how does this final amazing conversion happen? Well, as you can see here, when that stapes bone pushes on the cochlea, it creates waves in the fluid inside. These waves then cause thousands of microscopic hair cells to bend, and that bending motion, that is the magic trigger. It generates a tiny electrical spark, a nerve impulse, that finally gets sent up to the brain.
So the cochlea handles the hearing part. But remember, the inner ear is a master multitasker. So let's take a closer look at how this tiny space manages both sound and our sense of stability.
And this chart just brilliantly illustrates the division of labor. On one side, you've got the cochlea and its dedicated cochlear nerve, all for sound perception. And on the other side, the vestibule and semicircular canals use their own fluid and hair cells to detect your head position and movement, and they send that info to the brain through the vestibular nerve. Two completely distinct systems working side by side in perfect harmony.
So let's just recap that whole incredible journey. A sound wave is collected by the outer ear. It's converted into a physical vibration at the eardrum. That vibration gets amplified like crazy by the middle ear's tiny bones. It's then transformed into electrical signals in the inner ear's cochlea. And finally, it's sent to the temporal lobe of your brain, which says, "Aha, that's the sound of a guitar."
It is an absolutely stunning biological process, and it's happening countless times every single second without you ever having to think about it. And that kind of leaves you with a final thought, doesn't it? If this is the complexity behind just one of our senses, what other invisible marvels of engineering are at work inside of us right now that we completely take for granted every single day?